Hello, my name is Maham, and we're the Extreme Mashers. Our data structure is Tango Trees, and before I move on to what our application is, surprise, surprise, it's search engine, but I am going to explain about the Tango Trees a little bit, our data structure, namely. Um, so to put it simply, uh, Tango Tree is a fast searching tree, which just means that it complete searches in log n time, which is comparatively really fast, when you compare it to other um, trees, bsts, etc. And it is an online competitive tree. How it is structured is it is basically made up of auxiliary trees in our definition. How we implemented it, it is simply a red black tree. So it is composed of multiple red black trees. And okay, so one special property how the whole thing comes about is every single node um, in a tango tree is has a preferred property. Now the preferred property is based on if it has been traversed in in the last conducted search. And for example, if I take this tree for example, and where every red node is a root node of another auxiliary tree. So for example, if I want to search for 21, I go from 13 to 33 to 21. Now because we traverse through 33, that will be a preferred node, as well as 21, which will also be a preferred node. Now these preferred properties create a way for us to make preferred paths, because you have you can move from preferred node to preferred node to preferred node to create a preferred path. Now this preferred path is used to create auxiliary trees, which you can see over here. So over here we have an auxiliary tree which is composed of the nodes 13, 11, 33, 10 and 9. Now because okay, so this structure is also named as a forest of trees. Auxiliary trees hang from each other. As you can see, we have one auxiliary tree 12 which hangs from the node 10. We have one auxiliary tree 21 which hangs from the node 33. We have one auxiliary tree composed of 53 and 43 which hangs from this node 33 over here, and etc. Now because it is composed of multiple red black trees, it is said to be extremely balanced and is thus extremely fast when we want to search for something. Whenever we want to search something, a simple cut and join algorithm, when we move from one preferred node to a non-preferred node, a simple cut and join algorithm is needed to conduct the searches and retain the whole structure of the Tango tree in itself. Now, one important thing to note about the Tango tree in itself is that it only supports searches. And because it only supports searches, we cannot insert anything in it. It is said to be very static. And because of its fast searching ability and because it is static, we decided to um, create a project which retains both, which you know lends to both of those qualities, and create and thus implemented it in a database or a search engine. Because so the search engine has a large database which needs to be traversed through really fast to conduct efficient searches, and that is partially what our project is about. Thank you. And my partner will move on to explaining what our application is.